Welcome to DeFiChain Demystified, where we dive deeper in special topics around our project. The goal is to bring answers to some tricky questions and maybe bust some myths. We are
Hugi,
and Lord Mark, and today's topic is...
what the fork is a chain split?
Welcome back, Hugi. How are you, my friend? Long time no see.
Yeah, nice to be back. I'm good, thanks. It's a bit cold, but besides that.
Cool. That's where you're wearing a hat. Hey, guys, we are really stoked to be back. We were thinking to bring you a special for Christmas. That's why Hugi wears the Santa Claus hat. I was actually looking for one, but I could not find one. I think, I don't know. Impossible to find. Hugi, Santa Claus, I hope you brought a big bag with surprises for us today and one of these fantastic, amazing animations that you always prepare.
Yeah, a stop motion graphics, right?
Stop
three pictures and that's it.
Okay, that's absolutely cool. Hey, we thought the topic is really needed to talk a little bit about because in the last hard fork we had a chain split. Now the question is, what is a chain split? And we wanted to dive a little bit deeper in there because it's a little bit confusing for some people, and I fully agree. So I thought, let's talk about it and see what's behind that. Is it evil? Is it all fine anyway? So bit drama here. Okay, Hugi, I would say do you want I jump right into your graphics, or you want to start the other way? Okay, here we are.
Let's just jump in.
Cool.
We always have to start with the classic, right? The history of chain splits is the history full of misunderstandings.
Absolutely.
And I mean, especially since our last hard fork, the name or the word chain split is a bit like, oh,
it sounds super scary, like something is really
it sounds
broken,
scary,
right? Yeah.
But the weird part is, the reality is we have chain splits all the time, and no one notices. So let's talk about chain splits and forks and the myths behind it, or bust some myths, as we want to say. As always, super graphics. The stick figure is
beautiful.
Again, it's still not fat because now we are at 50 cent. I think the last time we had
bear market,
one.
Guys. The stickman has
nothing to market.
Stickman has nothing to eat.
Bear market miner. So when we have a blockchain, so it's all about today we are all about the chain level, really on the blockchain. And when we have the blocks, and just as a quick recap, a block consists of a list of transactions, and we have the Coinbase transaction. So the Coinbase, that has nothing to do with the exchange Coinbase, just for those who don't know that. Coinbase is the term for the block rewards that gets created or minted in the block. That's the Coinbase, basically. That's where Coinbase has its name from. So each block creates coins, and then there are transactions within this block that gets into the block, and then so they get into the chain with this block. And we have the block just started. I should have made an arrow here. So it's just somewhere within the chain. We have block 100, and then a miner finds a new block. It's block 101, again has a Coinbase and transactions in there, and is connected to the previous block. Then we find another block. So that's how we have this blockchain, a chain of blocks that just moves along. And it depends a bit on what chain we are on now. So what consensus? Yusin called it, or it's called the Nakamoto consensus. Is basically proof of what most of the people understand as proof of work, where basically the decision who finds a block is purely probabilistic. So there is a probability for everyone in the network. There is a probability to find a block now. For Bitcoin, with the proof of work, where it's just calculating the hashes all the time, and the first one who finds the correct nonce for the hash finds a block. It can happen that multiple people find the block at once. And DeFiChain has the same algorithm, but not with proof of work, but with the staking modifier on top of that. So it's still the same idea behind it, that every miner has a probability of finding a block, but it's depending on the time and the modifier. So there is a probability on that, and there is a probability that two find a block at the same time. So two miners find the same block because it's matching with the times and everything.
First short question, and first interruption. You said it's a proof of work chain, but with staking on top. So could we call DeFiChain then kind of a hybrid chain?
That's an interesting question. Basically, I mean, if you listen to the podcast of Paddy with Yusin, I think Yusin calls it a proof of stake and work or on work or so. So a bit of a mixture, because the algorithm behind it is based on the proof of work algorithm, but without the need to do the work, basically. So instead of doing the work, you have your stake.
Okay, that means in Bitcoin, you have to put all this computing power in to solve the puzzle. Here, nobody has to solve the puzzle. It's pure luck to find a block. It's like a lottery.
Yeah, and your luck is based on your stake. So you have the staking modifier and all that stuff, and it's depending on the time. You have still this. It's a probability that you find it. There is no nodes in the network decide and vote on who is allowed, who finds the next block, who is assigned the next block, because then it would be deterministic who really finds the next block. It's every node itself can try to find a block based on the current time and on the modifiers and the transactions and everything. So with that, because that's important now that we have this probabilistic part, because if everyone in the network knows who will find or get the next block, you won't get chain splits, or usually you don't get chain splits. With this probabilistic part, you can have the situation, and now we have our first chain split. We have the situation that we have miner A who finds block 103, and we have miner B who at the same time, roughly at the same time, finds not the same block, also a block 103 that matches on the chain. Those are not the same block. They have the same block number, but because they have different Coinbase transactions, because this Coinbase goes to miner B, this Coinbase goes to miner A, and maybe they put in different transactions, maybe they put in the same transactions. Usually they put in the same because they saw this a mempool and all. So it's probably the same list of transactions in there, but it's a different block. But they find it at the same time or close enough to be at the same time.
Question.
Yes.
Same time. Is same time meant to be like about these 30 seconds that we need to find a new block? Or are we talking, because on blockchain there's no time in some way, right? There's no seconds or minutes. So within these roughly 30 seconds, right? Is that what you mean with same time?
No.
Okay.
No, that's the topic. It's complicated. The thing is, as you said, on blockchain you don't have a time. But also we are in a network. We are in a worldwide distributed network. So it's basically time in the blockchain is based on how many blocks do we have. So as soon as someone finds a block, they send it to everyone else. And everyone who gets the block says, okay, I add that, it's valid. I have a longer block now, longer chain now. So time in the chain process with one block. When I say the same time, basically, I mean, everyone is on block 102 now. Now, having a chain with 102 blocks, miner A finds a block and miner B finds a block. And they find the block before they heard of the other one finding the block. So they are all still on 102. And now they find the next block, which is 103. This could be because it's in real world time at the same millisecond, and they are sitting next to each other, but they find it at the same time. It could be that the one in the US, the other is in Australia, and they find it with 100 milliseconds apart, but they didn't hear about the other one. Or there was a network problem that the one block didn't get broadcasted to the other one, and stuff like that. So it's just that they didn't know of the other block, because if they knew from the other block, they would have added that and then mined on top of that. But that's
makes complete sense. Makes complete sense. Okay.
Same time.
Okay, so the delay to relay the information through the network, in that time, more or less, somebody could find some. Okay. Yeah. Okay.
basically there are a lot of reasons, a lot of possible reasons why miner B didn't know of the block miner A found, and therefore made an error. It could be that he says, I don't like that block, honestly. It could be that they say, I ignore that block and mine my own block and broadcast it to the network. Could be. We don't know. It doesn't matter. But these situations, because of these network effects and time delays, these situations occur on a frequent basis, because then two miners find the same block, they broadcast it to the network, and in the network, now we have a chain split. We have part of the network that's on block on the block A, basically on the chain A, and we have a part of the network that is on the chain B, and that's a chain split, and no one cares about it, basically, because what's happening now is that everyone on the network who is on chain A continues to mine and tries to find a block on top of that one. Everyone in the network who is on chain B tries to find a block on that one. And now we have, again, the probabilistic, where is the next block found? Theoretically, it could happen that it's, again, two blocks are found on both chains at the same time. And we have a longer chain split, and they work in parallel. But the longer we go, the less and less and less the probability goes that we always find two blocks at the same time, basically.
Could it happen, Kügi? Sorry, interruption. Could it happen that now we have a chain split here, right? That the chains split again and then again and again, that on the top chain also two guys find the block at the same time and this chain splits there? Okay, that's also possible.
I mean, when we talk about probabilities, that's like super crazy. That's the same, like, how realistic is it to have two bombs in an airplane? It's like take one bomb to the airplane, because having two bombs on the airplane is super unrealistic. But that's the thing. It could happen. It could happen that here people mine, and here we have the case. If people mine on this one and get a split here again, it could also happen that they have a split here again, and we have four chains. But super unrealistic because of all the probabilities that they happen at the same time.
Get it.
But yes, and that now we are also at the point, because sometimes people are like, why do we need confirmations in a network?
Yep.
This is why we need confirmations in a network. Why, if you send something to an exchange or anything, you usually don't get it at the first confirmation on the first block, because assuming you have a transaction and it's in here now, it's in block A, and block B, for whatever reason, didn't take your transaction because they didn't know about it yet. If the exchange accepts it as soon as it's in the first block, and then this block wins, suddenly this is no longer in. That's why they usually wait until it's clear that this is the longest chain. Because how does it continue? The question is, we have a chain split now. It happens all the time, but we always see it's only one chain. It's one blockchain, and it's immutable and everything. So what's going on now? The thing is, how this continues is we have both chains, and now let's say the chain A is the first one who finds a new block. In theory, as we said, it could be that both finds one at the same time. Then this applies. Just imagine here being a bit more blocks. But in the end, one of the two chains will be the first to find a new block and be the longer chain. And now there's one important thing. The most important thing is that both chains are completely valid. Means all of the transactions are fine, all of the blocks are correctly mined, and they are all valid blocks. So any miner, any node in the network would accept both chains. Because then, now, everyone on B looks at this chain and gets suddenly the information from somewhere in the network. There is a block 104. He compares that with, I have a block 103. There is a longer chain. It doesn't match my chain. I need to switch to this chain. So we have the switch that we say, always go to the longest chain. We ignore this chain because this is now the shorter chain. Everyone stays on the longer chain, and miner B, basically everyone on the B network, let's remove that. Everyone on the B network needs to remove all those blocks that were split here, or that were this, I don't want to say fork, but it's a fork, but we come to the fork later. Everyone who was on this chain fork, basically, needs to remove all the blocks that they had that are now abandoned, we move the Coinbase, we move all the effects of all those transactions, go back to block 102, and then apply the new 103 and the new 104.
Does it mean that miner B in that case loses his reward?
Yes.
Okay. What if he would? But the reward is not spendable, because if a node finds a block, you cannot spend it anyway for a certain amount of blocks, right? So it's kind of
yes
locked.
and no.
Yeah.
The thing is, if he spend it, he would spend it on this chain.
And that's all voided.
As soon as this chain, and this is all gone after. That's why this all needs to be reverted, and this Coinbase needs to be reverted. Everything in here is reverted, and that's a reorg. It's a reorganization of the stuff where we say, okay, I have to remove all my stuff and go to the longer chain.
Okay.
The longer chain always wins. That's also this proof of work. The majority of the network wins.
Okay, now I have
those who have a consensus.
New challenge for you. What happens if there are two chains and they are the same length for a certain period of time? Then you cannot say, okay, there's a longer chain. Everybody says, oh, I've got block 104. And then the other chain says, oh, we've got also 104. And then it's 105 at the same time. So could this go on for a longer period of time, that the chains have the same length? Or is this also not probable, at least?
It's not probable. It's theoretically, yes, but it's not probable. The thing is, there's already a pretty low probability that you have that.
Okay.
I mean, in big terms, it's a low probability. And having that, and again, the same thing, that both find a block, because it's basically the two miners find a block at the same time, there's a low probability that this happens.
And that the 104 is found at the same time again becomes the
it's again the same thing, that two miners in the network find a block at the same time, and again and again and again, so that the probability goes down exponentially. So, and that's why it usually don't have, and that's why we don't have a confirmation of 1 or 2, but a confirmation of 30, for example. I think Cake has 30 or something.
Yeah, some exchanges have 75 confirmations or something like this, right? It takes
something
forever.
like that. It's usually they are high confirmations. It's a longer time. Because then the probability is basically zero. It's in theory, it's still there, but it's basically zero. And that's the thing with probability. You never know 100% certain, but it's so low probability that it's really, 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 really low.
Okay, get it.
But that's the thing with the chain, and that's why a chain split. So with one, it could happen, not with every block, but it happens frequently. But then we have another one finding the first block, the first longer chain, and we revert that and we go back to that.
And this this situation or this action is then called a rollback, or what's the name for it? Or you said reorg. You called it a reorg.
Yeah, it's reorg because different people have different names for stuff. And we need to be careful with what we call a rollback, because usually a rollback is used, the term rollback is used for when you say something happened here, it was a valid chain, but we don't like what happened here. I think there was shortly a discussion when an exploit happens or something like that.
Yeah.
Then
Ethereum had that once, right? Ethereum did this once, for example.
It's called a rollback when we say, okay, that something happened and we didn't like what happened on the chain here, so we go back to this state. We roll back the chain to this state and start from there. That's what's usually called a rollback. I mean, technically, here the chain B does a rollback to 102 and then continues here. So technically, it's the same thing because you're rolling back. Reorg is usually called when you say, okay, we have one chain and we have a different chain and we have a small reorganization because the network part B needs to reorganize their transactions that they are now on this one. Reorganize the block, so it's a reorg.
Okay, makes sense.
That's like what is meant with what word. So that's a bit that topic. But that's what's happening here. And the important thing is that all of this is correctly rolled back or reorged and removed, that this like it never happened for those part of the network. And that's basically so that's a chain split. That's how a chain split generally. It's just that the chain splits, and after some time the longer chain wins, and that's also I mean, just as one note, people always often talk about the 51% attacks. That's basically the same thing when we say, okay, we run here, and one miner, for example, miner B, do that in silence. So they don't tell anyone about the blocks, but mine the blocks. Everyone else is on that blocks chain, and they have that longer chain, and then suddenly tell everyone. Then you have a reorg that everyone else needs to abandon their chain and go to the longer chain because the longer chain wins. And suddenly you have a big reorg back to a different chain that could be different. And that could happen if the majority of the network is on a different chain. That's why you need 51%, that this chain really gets longer. So basically, in the end, the chain wins where the majority of the network is on. And because they find more blocks, so they find more majority of miners, not the network.
I think that's very important. So it doesn't mean that only being the longest chain gives you the priority, but you have to have also more people on that chain in some way.
No, it's the thing is the longest chain wins.
Yep.
That's it. But how does a longest chain get the longest chain? The longest chain becomes the longest chain because the majority of miners are on that chain and making blocks.
So you want to say that's why a single node cannot produce so many blocks. It's impossible. It would be kind of It's like work, right? If you pay 10 people doing the work together, they most likely going to be finished sooner than one person. It's that approach, right? You need more people to find blocks. Okay.
And for proof of work, that's the thing where you say, okay, if you have 51% of the hashing power, of the mining power in the network, they likely get the longest chain because they have the highest probability to make the most blocks. And that's why you have the longest chain. So that's how a chain split happens and what's happening. So it's a normal process. And now the question is, what is a real split kind of, where we say, okay, that's not the normal process, or part of the normal process. So assume now that miner A put in a transaction, and I call it invalid, because miner A puts in a transaction that miner B considers invalid. So miner B cannot take this block into his chain because he says this block is invalid.
Okay, for example, it is considered as cheating, or he spent something that is not available or something like this, right?
Yeah, technically it's just a transaction that's not valid in the current consensus.
Yeah.
And this could be that miner A is doing something bad and tries to do a double spend or whatever, what miner B says is not valid. Also, and now we come to the fork part, also, if we have an upgrade in the consensus that we say now, for example, a new feature comes in. What we had with the governance for the last chain hard fork that we had, where the on-chain governance comes in. So we have new transaction types, new transactions, new opcodes that come in, where we say now people can update their master nodes. That's a new transaction where the old node software would see that as an invalid transaction because they don't know that, and it's an invalid transaction. They don't accept that, for example. Could be. When we say there's something that's not in the consensus before, they see the transaction and say that's an invalid block. I don't mine on that. I don't take that in mind, and I mine my own block. And everyone who is on this consensus and accepts these transactions finds new block, and we continue here. And that's why this is called a hard fork, because everyone who is on the old consensus is forced to not take this. And you must upgrade to the new consensus, to the new node software, to the new level, to be in the state where you say, okay, I accept this transaction. This is valid in my consensus, so it continues. That's why if you have a hard fork and you stay on the old node level, that's why it's always mandatory to update the node software, the full node, if there's a hard fork, before the block where it's happening. Because the consensus says, beginning on block 103, this transaction is now valid. And if you don't update, you get on an wrong chain because you don't accept that one. Maybe you are a master node, so you mine the wrong blocks.
Okay.
And in theory, and that's something we had with Bitcoin, where we had these forks with the block sizes and everything back 2016, 17, I don't know,
17.
long time ago, where we had this forks from Bitcoin, where some said we now want bigger blocks, others said no. So suddenly we have a fork where the chain really splits into two chains that continue, and the one is the Bitcoin Cash, the other is Bitcoin.
And normally the old chain is dying, right? But I think it's a very good example that you gave that the old chain is not dying. They both exist. It's like Ethereum Classic and Ethereum, right? Everybody thought that Ethereum Classic is gonna go away. It never did at the end. So the party pooper stayed on the old thing, but it didn't die. Yeah.
Yeah, get on the haters. Do that. Good luck. No, the thing
Nothing
is,
against Ethereum Classic. Don't get me wrong.
yeah. We just call it party poopers. But that's the thing is, and that's the beauty of decentralized systems. No one can force anyone to change. I mean, in the end, if the majority of the DeFi chain community would say we don't like the new update, we don't like on-chain governance, the miners and everyone says we stay on the DeFi chain core 2 point something,
then it's not happening.
Then some of the miners get the new chain, some of the miners have the old chain, and suddenly both chains are there because there are people doing it. And if there's a big a sizable part of the community that does that, this chain would survive and would still be there, like we have it with the Ethereum Classic and Ethereum.
Then the question is just, where's the value, right? Where do the investors actually see more value? And there might be the possibility that people say, no, actually, I think the old DeFi chain is worth more. Then it could even be that the old, not upgraded chain becomes the more valuable chain at the end.
It depends on who is staying on that chain and who is doing it. It's like we had it with the Bitcoin forks and everything. Bitcoin Gold, Bitcoin Cash, Bitcoin Satoshi Vision and everything.
Cool.
If enough people think that's the better chain and stay there and trade that coin, because those chains you can't, that's also why when we had these forks in Bitcoin, everyone who had Bitcoin before the fork now have the Bitcoin on both, because the old transaction says this address has so many coins, the old chain. So now they can spend it here and they can spend it here. They just need to be careful about double spends or double replay transactions. When we transact it here and someone sniffs that transaction that goes into this block and puts it into a block on this chain side too, because it's a signed transaction using a UTXO from back here. So suddenly you do it here again. So there's different topic, complicated stuff to prevent that. But that's why chain splits are, with hard forks, you have that as a normal procedure. And it's just for us, when you say you do a hard fork that updates the consensus, that changes the consensus so that the old consensus doesn't accept the new ones. Usually we do that because it's good for the community and we have a consensus in the community that we want to do that. So everyone in the community updates. And that's why the old chain usually dies out, because no one is mining a block there anymore. So you have that and you continue on that.
Now I wanted to ask you actually, but you gave 90% of the answer already, but let's do it again just to repeat it. I wanted to ask you, so why is DeFiChain actually having so many hard forks? Because compared to other chains, we don't hear so much about hard forks. Maybe you can elaborate on this a little bit.
Because we are building like crazy.
Okay.
In the end, it's like we do a lot of stuff. And Bitcoin doesn't really do a lot right now. There is not much of development and improvement on a consensus level where we say new features come in or anything. There is not much happening there. And also other chains, there is not much happening because that's normal. In the beginning of a project, you do a lot of stuff. You need to improve a lot of stuff. You want to build in new features. Also, I think one of the major things for why DeFiChain has so many improvements is because we did all the DeFi related stuff on a native level. So a pool swap, a vault, all those actions are on a native level. They are in the consensus. They are not a dApp on top. They are in the consensus. and therefore the consensus need to change as soon as this comes in. If we say we add liquidity mining as a general, not one pair, but liquidity mining, the possibility to liquidity mine, adding that needed a consensus change because it was something new directly on the native level. Same with the vaults in the D-token system. Same when we added the future swaps. When we now have the on-chain governance, that's native on-chain. When we do the lock pools now and all that stuff, that's all on-chain. But now when we move to the DMC, where we say, okay, we have a lot on the on-chain, on the native level now on the consensus, and now we will add this Ethereum virtual machine, or it's Solidity, so it's the same virtual machine, the DMC, on top. This allows for a lot of development where we don't need any change in the consensus. There we will only have a change in the consensus if we say we change how the virtual machine is executed and stuff like that. So there will still be hard forks because we improved that and add possibilities there for automation and all that stuff. But that will likely reduce the number of hard forks that we have because the consensus updates will get less and less. Because we don't need that. Right now we want that because we improve, we move forward, we get new features, we got new functionality and all that stuff. And every time we get a new functionality on the consensus level, we need a hard fork because those stuff that is done there would be invalid in the old consensus, in the nodes that did it before.
Okay, very well explained. Cool.
And yeah, that's basically how then a real chain, that's why I say a real chain split, as soon as there's something in here that's considered invalid, but this chain becomes the longest. And that's also one important thing. Because if we have the case where we have a bad actor that says, I want to put in a transaction that's invalid, that's really invalid, a bad transaction, then usually the majority of the network will just ignore that transaction or that block, invalidate the block and make a longer chain. So the wrong chain would die out. But if this chain where some of the part of the network sees it as an invalid transaction is actually the one where the majority of the miners are on and they accept that, then this is the longer chain. And then if you have, for example, 60% accepting the transaction, 40% not accepting the transaction, we get this. And that's what happened in our case because of a bug in the code. And that's also a bug with the chain splits because the rollback of the Coinbase, if a normal chain split happened, the Coinbase that was given here, that this new created Coinbase that deposits the unused block rewards to this address, this rollback wasn't 100% working correctly. And therefore, the balance that the node thought this address has was wrong. So some thought it has a bigger balance because they didn't revert the Coinbase when they reverted the normal chain split. So somewhere in the back, a normal chain split happened. Some miners, basically those miners, had to revert and had a bigger balance on this account. Then this account had this information from this chain where he thought he has a bigger account, did this transaction using all that account. The part A of the network used this transaction as valid and said, okay, let's put it right in. They said, no, wait, you don't have that balance yet. You need to wait a few blocks. So this block is not valid. So they didn't accept that one. This was invalid, but the majority of the network was on that block, on that chain. So this chain got a bit longer. The other part of the network still continued on that chain. And then we had a real chain split. Let's call it real chain split because more and more blocks came up because even though this was a longer chain, this part of the network couldn't switch to this chain because this was considered marked as invalid. And that's how the real chain split then happens. If we have something that makes part B not accept the longer chain.
Okay. So how was the problem then solved? Maybe that's also interesting to know. How can you then force a network to come back on one chain in some way?
Basically, there are multiple ways to solve it. The easiest way to solve that or do a quick workaround is to tell everyone to invalidate this block so that miners A, even though they think it's valid, say this is not allowed and they switch to the other chain.
Okay.
That's the easiest, but then the problem is not solved, but the chain is back to a consensus. Then we probably have the same problem a few times later.
Okay.
How it's solved in this case was that the bug was fixed so that this rollback doesn't occur anymore. And as soon as this updated version came out, the miners had to update the version and basically start resyncing back from somewhere here.
Okay, so they took they went back to a screenshot, downloaded a screenshot.
A snapshot, not screenshot, but
yes.
Snapshot or a backup, or do a full reindex.
Okay.
Because the thing is, this invalid transaction only got in if during the normal working computations, we had a chain split calculation, a rollback calculation of a reverting of one block. So if we do a new sync, this transaction would have always been invalid. So if we would do a fresh sync, you always get there and always took this chain. So that's how you then easily know which chain is the correct one. And then you say, okay, this is the valid one. You have to invalidate this block or do a fresh sync. Then you anyway get that because you invalidate that. And since we now have a node update that only that does that correctly, so it never comes to the situation again that they have that and think that this transaction is valid. But since it's not a hard fork now, it's just a node update. And that's why it's deactivated, that it doesn't happen. So this transaction is not happening right now. So such a transaction cannot happen again because we don't use that amount, that account right now. That's why the DFI accumulate, but they are not spent, because as soon as they are spent, there is a really, 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 really low
that somebody
chance
says, no, you can't, and I don't accept your block again. Yeah. Right? Okay.
There's a low chance that it takes a too big part of that because the whole situation happened again. The majority of the network is on the correct software now. So it should be no problem, but yeah, better safe than sorry.
First.
And since the DFI are accumulating anyway, it's like, yeah, let's burn it, start burning it with increased speed. On I think January 10th is the current timeline.
Yeah.
So it's not that long a time, and then we burn with increased speed. So nothing is lost. It's just a bit delayed, and then a stronger force, which is good. Yeah, and that's how it's solved basically. Everyone updated, majority updated. So now the longest chain is always the correct one. So even if something like that happens, theoretically, that would be the smaller chain, and it will be that it would die out soon.
Good. So now we know what is a fork, what is the chain split, what really happened, and it was not a screenshot; it was a snapshot. Cool. I think that's amazing. That was really good stuff, Kügi. Especially, we always hear people. I mean, we are always talking about hard forks, right? A next hard fork and a next hard fork and a next hard fork. But I think a lot of people might have thought, why do we need all of those hard forks? Actually, you also explained that very well. Cool. Something else to add? Otherwise, I think we are pretty much done for today.
Happy holidays.
Yeah. Hey, let's switch back here. Let's see Santa Claus here. Hey, Kügi, thank you so much for the amazing infographics, animations. I hope our little skinny stick man is getting fatter over time, that the miner making more money. Guys, from my side, we wish you a Merry Christmas and a Happy New Year. Kügi, I gonna see you most likely 2023, and then we gonna bust some mess again here.
Yeah.
Absolutely. Hey, Kügi, thank you so much for coming. I really appreciate this. So, in your busy schedule, just before Christmas. And yeah, see you next year. Thank you very much. And bye-bye.
Bye.